I want to talk about how you start a new program. This is actually a topic that doesn't really need to be covered in CSE2. It doesn't really need to be covered until a little bit later, because the truth is that as software developers, you are almost never starting a new program. Why is that? Because most of the time, what a software developer is doing is they are taking code that somebody else wrote, and they're finding bugs, adding features, and solving problems that are affected somehow by that code. So you generally do not start new code yourself, because if you think about it, how many new pieces of software are actually created as opposed to the number of programs there are. There's like the number of programmers that there are. There's clearly way, way fewer pieces of software out there. So with that said, you guys will typically be writing code from scratch. And well, that's not entirely realistic. That's just a matter of the fact that you guys are taking courses and you're creating code that is used to demonstrate your abilities. So I'm going to teach you some practices that you should know about, just so that you have a sense of what you can do to make things easier for yourself, and also so that you can start thinking about your own practices in terms of making things easier for you personally, because it occurs to you how to make things better when you've seen these ideas. Okay, so the first good programming practice I want to tell you about is to always start by writing comments. And this is actually a piece of advice that would probably be best heard after exam 1 in this middle of the class, because you start writing much more complicated code in the second third of this class after exam 1. And like right now, writing a complicated long comment describing how hello world works seems really superfluous, and that's because it kind of is. You don't need to write detailed explanations of what hello world does. So that's why this particular suggestion doesn't seem to make the most practical sense right now, but it will. And we have the opportunity to talk about it now because we have a little bit more time in the beginning of the class. So the reason why you always start by writing comments is it begins to focus what you're thinking about writing. And if you have a very complicated procedure to write, the comments that you write turn out to be kind of a to-do list. They remind you to write certain things into your code so that they get done later. If you rely on yourself to remember, oh, I need to take care of this, oh, I need to catch this situation, then you may not actually remember when you're in the middle of writing your code. You might be distracted with something else. So writing comments first is a great way of helping yourself avoid forgetting. And it's also convenient because it might help somebody else understand what you're doing, which is also the original purpose of comments. Okay, so when we start a new class, and you guys will be starting a lot of new classes, like Hello World and other things, note that the class construct is these 3 words: public class, the name of the class, and a pair of curly braces. So I just want everybody to remember that these curly braces have to match. You can't have one curly brace and not the other. Java will always tell you that there's an error if you don't have that. More importantly, if you have some mismatched curly braces, Java cannot tell which curly braces should match which curly braces. It doesn't know what you intended. It only just knows that there's mismatched curly braces. So if you develop the habit of always making both curly braces in a pair anytime you make one of them, then you could just simply never have that bug. You just never have that problem. It's sort of like the habits that we all develop to avoid losing things. Like I happen to carry a gigantic keychain because I hate losing keys, so I just carry all my keys with me. It's maybe not the lightest set of keys, but it's a great way of not forgetting the keys. This is the same thing that you can do here. You can develop a habit that simply prevents annoying issues from happening later, like hunting for a missing curly brace. Also notice that anytime you generate a class, you have to have this incantation, public class hello world. And you'll know a little bit more about the word public means later. But for now, just accept that you have to write these 3 words, or these two words and the name of your class. The other thing I should point out is that the name for your class, Hello World, with its capitalization, must be identical to the name of the Java file. So the file helloworld.java had to have exactly the same capitalization as this word here. Like you had to capitalize the W. There was one person that I worked with the other day that had a lowercase w, and this is something that can come up. And it can be confusing when you see that and you're like, I don't understand why this would work. It says hello world, right? So just know it has to be exactly the same with capitalization. In fact, anytime you expect Java to know what you're referring to, you must have exactly the same capitalization and spelling in every case that you refer to a variable. Okay, so I suggest writing, after you've made this curly brace, and you can fill in the things that go inside that curly brace. So I suggest writing the main method after you've made the two matching curly braces for the hello world. And note here that I've tabbed them. This tab it has nothing to do with Java. It's called white space because it's space that's unoccupied. But the reason why programmers tab code that's inside a curly brace is it helps them to distinguish what code is inside and what code is outside that pair of curly braces. It also helps to avoid errors of matching curly braces, because if you have a pair of curly braces and all the code inside is tabbed over, then it's really easy to find where that missing curly brace should go. So that's why this code is tabbed in. And I strongly suggest that you adopt this style, where you tab in code inside curly braces so that you avoid A, missing curly braces, and B, clearly make the code easier to read for yourself as you work with it. Now, right now, you're seeing the most basic code where we have a class and a main method, both of which are required. And anything that you would write would be tabbed in a second time inside the main method. Later on in this class, in fact very soon, you're going to learn about other constructs which have their own pairs of curly braces. And those constructs can be nested together. So you can have many layers of tabbing. And it's okay to have many layers of tabbing. That makes your code easier to read. There are very, very rare circumstances when you might feel like you have to scroll the screen to the right. But we have widescreen monitors these days anyway, so it's not really an issue. You may notice that in Code Anywhere, the tab depth is 2 spaces and not 5 spaces like it is here. You can adjust the depth of that tabbing to your preference. This is really a visual thing designed to make things clear for you and other programmers. Programmers that do not tab their code correctly are generally regarded as people that have no idea what they're doing. So you really should do this because it's stylistically tasteful. Okay, so every program requires a main method. I didn't explain why earlier, but you need to have a main method because that tells Java where to start. So in one of our first lectures, I described a program as being a list of instructions, right? Where you start from the top instruction and you go down the list of instructions. This public class hello world, public static void main, tells Java where the beginning of that list is. And later on, as you learn more sophisticated constructs of Java, you'll learn that you can actually have code up before the main method. And the reason why you can have it up before the main method is because you can have redirections that point to that code. The reason why Java doesn't get confused is that you must have a method called main, which tells Java where to start. So having the main method there always indicates the beginning of the list of commands that will start in your program. And so that's why every program has to have a main method. In fact, this is true of many other programming languages. In C and C++, you have to have a method that's called exactly lowercase main, which dictates where the code starts. Okay, so this thing, a method, is sort of a container for code. And later on in this course, we're going to learn about other kinds of containers. In fact, we're going to learn how to make our own methods. But right now, it's the only container that you have inside the class. So you can imagine that the class with its curly braces makes a container for code, and that the main method with its curly braces is a nested container for code, and later on we're going to have some other containers. But right now, the main method is the only container that we're working with. Okay. So I think that's all I want to point out. There's one other question actually that several people asked me. So after you compile Java, right, what the compiler is doing, this should be lowercase j, what the compiler is doing is transforming your code, the code that you wrote, also known as the source code, into a language that the computer can understand for actually executing the program. So you may have noticed that after you run the compiler, that you see a new file show up in that folder called, in this case, hello-world.class. So hello-world.class is this other file, and it's actually what's being run by the computer when you are running that program. So the source code is not actually being executed like on the CPU. It's actually just a description for the code to be made to run on the CPU. And that's one of the distinguishing characteristics of higher level languages, which are always translated into lower level languages for the computer to run. As you continue your study of computer science, you'll find that there's all sorts of cool innovations on how this can be done. You can actually make your code run faster when you translate from higher level languages to lower level languages. But these are things for later. The important thing to know is that the code that runs is the .class file. Okay. All right, some other things that I want to get to. I want to show you this example that we didn't get to talk about. And that's the idea that I might want to take the data stored in one variable and put it into another variable. And at the same time, or at a related time, take the data in that second variable and move it into the first variable. And so for lack of a better term, I'll call that swapping variables, moving the data in two variables into the other variable. So it might seem like you could write code that looks like this. If I had these two integers, val1 and val2, and they were assigned to some value, it seems like you could write code like this, right? Assign my val1 to my val2, assign my val2 to my val1. That moves data between the two variables, and it seems like it should be fine. But this doesn't work, and this doesn't work because these commands are happening in sequence order. So remember, Java is a list of commands. It does the command on top before it does the next command. And so what happens here, when you assign my val1 to the value in my val2, is that you're going to overwrite the data in my val1 with the data in my val2. And then in the second line, you're going to take whatever is now stored in my val1 and store it into my val2. So what was originally 3 and 8 becomes 8 and 8 instead of 8 and 3. Because these two commands are not executed simultaneously, they're executed in order. Does anybody find this confusing? Okay, that's great. Because, well, this is kind of a technicality. It's a really good way of illustrating how exactly Java works and how you can catch the misconceptions that might happen accidentally as you read code. So when I see this, even now, I have this I don't know, animal need to assume that they swap the two values. Because, I mean, I was a math major in college. Maybe it's because of that, or maybe because of some other mathematical training. But this is counterintuitive to somebody who's been trained that way, and it may be counterintuitive to some of you. So just remember that you cannot swap values in variables in this way, and you can get yourself into trouble. So the way that you should think about this, and really the way that you can help yourself break down any list of Java commands, is to think about what is stored in each variable after every line is executed. So if my val 1 is equal to 3, then you can imagine that there's this little box storing the current value in my val 1, and it's equal to 3. And if my val 2 is assigned to 4, then you can imagine that there's two boxes now where my val 1 still has what it had, and my val 2 now has 4. When I run this next command, my val 1 is equal to my val 2, then we're literally going to take what's in the my val 2 box and put it into the my val 1 box, overwriting whatever was there. So now we have 4 and 4. So taking my val 2 and assigning it to my val 1 results in no change because the 4 is already in my val 1. By showing you this, I'm kind of inoculating you to this kind of mistake. But I want you to understand that this is something that's really sneaky, and sometimes when you see this, it doesn't occur to you that this sort of thing might be going on. So I'm not simply showing you the fact that you can't swap variables in that way. That's the example. I'm showing you a way to break down problems in code by figuring out what is currently stored in each variable at each line. Now, it's really slow, right? You can imagine yourself reading through code that might be much longer than this, and at each line of the code, writing down what's stored in each variable. And only after many lines of code do you finally figure out what's actually going wrong. Whereas what's actually going wrong here is sort of obvious after the fourth line. But the reason why I'm showing that to you is because it's also a very effective way of finding that kind of error. And sometimes effective, really tedious ways are much more effective at, or much more quick at finding errors than sort of looking at something and having an intuition that tells you what that error is. So by developing your intuition and also by following these really exhaustive procedures, you can find errors that might get overlooked. And that's what debugging is all about. You guys are in a few weeks going to have code that is not trivially debuggable. That isn't like obviously that isn't obviously transparent to where your errors are. And as your code gets more complicated, you'll need to adopt more sophisticated, more patient approaches to finding bugs. And this is the first case where that might come up. Okay, so somebody emailed me a question about pre-increment and post-increment. And that's a good sign because that means that they were reading the labs, reading the lectures after the lecture actually happened because we didn't get to that slide. I want to make sure that you guys are all reading the lectures also because these are describing the topics that you need to be aware of. And if we get interrupted because of questions, I want to address those questions, so I will definitely leave those slides out. But we all need to catch up with those slides later on because that's where we need to be with our learning at the end of each lecture. So pre-increment and post-increment is one of the most annoying and confusing things about Java and C and a few other languages that actually use pre-increment and post-increment. So the question that I got is, what's the difference? So just for those people who haven't seen pre-increment and post-increment before, what pre-increment and post-increment do is they add one or they subtract one from a variable. So if I have int myval, then system.out.println plus myval will print out 2. And system.out.println minus value will print out 0. And that's really convenient if sometimes you want to have a single line of code that is going to just add 1 to something and give you the thing after you add 1. Before, instead of saying int myval is equal to myval plus 1, and then having the line that you were going to have originally, you could just say blah 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 plus myval, and then you can take care of that increment. That happens all the time in computing because a lot of the times what a computer is doing is it's working on every member of a set or everything in a list. And so one of the things that it's doing is just going down the list and doing something to each member of that list. And How does it do that? Well, it just increments to the next thing on the list. So this sort of increment and decrement thing, it happens all the time. And so it's natural that you have this kind of increment and decrement syntax. Now, the reason why this is confusing is because not only is there a pre-increment, like I just showed you, there's also a post-increment. So the difference between pre-increment and post-increment is that pre-increment performs the increment before the line on which it occurs. So here, system.out.println gets a value in it that is equal to myval plus 1. Because inside this line, myval has already been incremented. Same deal here, except it's been decremented. Now, the difference is that in this line, myval has not yet been incremented, because in post-increment, it does the increment after that. So here, system.out.println is going to print out 1. And afterwards, if I just said system.out.println myval without any pluses, myval is going to be equal to 2. Because it's going to increment myval after the line on which the post-increment or post-decrement occurred. So these two lines here, this one and this one, will both print out, excuse me, if we assume that these lines are not there, sorry about that, and if we assume that this line occurs immediately after this, or that this line occurs immediately after this. If we run those two lines, they're both going to generate 1 and 1, because each one of those times, myval would not have been incremented until afterwards. If I added another print line afterwards, then myval is then going to be equal to 1. It's then going to be equal to 2 in the case of the post increment, or it's going to be equal to 0 in the case of the post decrement. Now, that's really annoying, and it seems like, why would you have both of those? Like, why would I have both pre-increment and post-increment? Why would I have pre-decrement and post-decrement? And I don't have a good reason for you why those two things exist. Maybe somebody can look it up somewhere, or Google why historically we have it. Some people prefer to always use pre-increment, and some people prefer to always use post-increment. But I have almost never seen anyone who uses both pre-increment and post-increment. That's just rude, because it makes it hard to read your code. In this class, I will challenge you by showing you examples of both. And that's because I want you to be able to read other people's code without getting frustrated. Reading other people's code is perhaps the most frustrating thing that can come up. Is something wrong?
No, sorry, no,
Like there's some sort of fire drill or something. I want you to be able to read other people's code without being confused. So that means that my exams will intentionally confuse you on these sorts of things. And for that, I'm sorry, but later on, you'll be able to work with other people much more effectively and be better coders yourself. Yeah.
So use the post increment argument. So we write the system out print line, and then we write another line, and then after that we would add.
No, it's the existence of these two pluses. Of these two pluses.
Would it add another value? So after you write another code,
Okay. So there's like an invisible line of code after this line that's going to add to. So you can. What this is saying is that right after this line runs, it's going to add 1 to my line.
Right.
So sorry.
So you can add more code in that line?
You could have more code in this line. Like you could have system.out.println myval plus 5. And that would print out 6. And afterwards, after this line, myval would be equal to 2. Because at the end of this, after the end of this line, myval is going to get incremented. Yes?
I'm kind of confused on how exactly you know when to kind of use these, or what the context of I guess
So there's almost no context in which you should be using both pre-increments and post-increments. You really should never have both of them, because Because in the end, these are identical to having a line after the code or before the code that literally adds 1 to it. So it's really a matter of how you want to save that line in the context of how a person is going to read that code. Because Java doesn't care. Java is just giving you a shortcut, and it's going to interpret it the same way. There's a plus plus operator, a minus minus operator, and it's before a variable or after a variable. It applies to that variable, and it's going to increment it either before that command or after that command. So to Java, this is transparent. But to us as readers, that's where the influence happens. So the most common place where you'll see the increment or decrement is in a loop. And we haven't talked about loops yet. But one important part of a loop is just this place where you just say, go to the next step. And that go to the next step is represented with an increment, almost always, like a plus plus or minus minus. And knowing how that works is crucial because you want to know how that loop works. And we'll talk about the loop later.
So when you say go to the next step, does that mean like in the same type of like activity or in like a separate, like starting completely different?
In fact, it would be in the same activity.
Okay.
But we can leave that abstract for now because loops are not until after the first example.
Yeah.
Okay, I realize that this is weird, and I also feel like some of you guys are holding back on me and not being forthcoming about asking questions. I want you to ask questions until we've completely eliminated any confusion. So I'm going to assume that right now we're all good with this, but I feel like there are going to be more questions later. So review this because it's a confusing topic. And anytime we have confusing topics, that tells me that I'm going to make annoying questions on the exam. And that also tells you that this is something that Dr. Chen might be trying to make enough questions about. So be warned. Christian.
All right, I'm like, does it add 1 to the next my value that you will have in your code, or does it add 1 to like the next line? So let's say you have like my val and you have my val 2. Would it add 1 to my val 2, or would it just add to the next my val that it finds in the code?
Oh, that's a really good question. So it's applying it to that variable only.
Okay.
So you have a variable called myval, and the plus plus or minus minus is going to basically change the value of that variable only after the end of that line or before that line starts.
Okay. So it wouldn't matter where it appeared again, it just would add it again.
Right, it wouldn't matter where it appeared again. In fact, if it didn't appear again, it might not matter, but it would still be changed in memory.
Okay.
Yeah?
Can you use the pre or post increment in an example, right, John?
Yeah. Your question as I'm setting this up?
Oh, I was just gonna ask, does it have to be in a print, or can you say like my val equals plus plus my val, and then it like reassigns it to?
Yes,
Okay.
yes. So it doesn't have to be in a print. That's a great question. So, so it could just be my val is equal to plus plus my val, and that would make my val equal to 1 more than it currently is. Or it could be in some arithmetic expression where, like, imagine there's my val 1, my val 2, my val 3. You could actually say int my val 4 is equal to plus plus my val 1 plus my val 2 plus my val 3, something like that. Okay, as I'm waiting for this, another question? Can you guys read the screen, or is it too small? A little small?
You can just zoom in with the
Oh yeah, I can do the. Okay, that has to be okay, right? I guess if it's not okay, I can't do much better. I might have a typo here or some sort of compiler error. Okay, so this is the code here, just printing out the value of my val, right? So here I'm printing out I'm setting my value equal to 1, and I'm printing it out with this, a little bit of sugar here, just saying that my val is equal to whatever it is. So here it prints out my val equals 1. Now, if I do this, okay, if I do this, then I'm saying post increment my val after this line. So in this case, it's going to print out my val equals 1, and then the next time, it's going to print out my val equals 2 because it's been incremented after that first line. At least that's what I'm claiming. Oh, incidentally, the way that I'm typing so fast is that I'm using shortcuts. So if you hit the up arrow, you can go to your previous commands like this, and the down arrow will go to later commands. So one thing that you'll do all the time is recompile, right? So just hit up and hit Java C, hello world. So easy. And if you want to test it, you can hit up twice, same deal, and this is what we have. So my val1 is equal to 1, and it's been incremented only after that line here. So the next time we print it out, it's equal to 2. But not until it's accessed again does it matter that it's been incremented. But it's incremented immediately after that line.
So if you were not to use the value in the next line, it would still store it until you use it again and then?
Yes, so the question is, if I were not to use that value in the next line, it would still be stored. So I could just say like, I don't know. Something like that. Then I could compile it if it didn't have a typo, and then like nothing would happen to it, but it would have already been incremented. And it will be permanently incremented after. Okay, so let's, just to make sure the horse is absolutely dead, let's look at pre-increment. Okay, so here I'm going to pre-increment this. Or I guess I'll pre-decrement this. And you will see at each step that how it changes. So here, before anything happens, my val is equal to 1. And then I pre-decremented it. So I've made the change before that line. So here, when I have this minus my val, I've changed it before the line. And afterwards, I increment. Or afterwards, it's printed out again. So it's still equal to 0. Okay, so does everybody feel more comfortable with how pre-increment and post-increment works? Yes. I haven't.
Abby,
Yeah, okay.
I know it's slightly pointless, but could you do like a pre and I don't know if someone asked this on the back too, but can you do like a pre and post like in the same?
Yes, you
plus-
can.
plus
I think you
plus
can.
or something?
So this is exactly the kind of question that you should be asking. Like, can I make this broken thing like even more crazy? That's completely what you should test, because Java as a language is promising you that any construct in the language will work. So even something that seems crazy should work. So let's see what happens. Let's do this. Okay, so maybe you can't do it, I'm sorry. So actually, what if, all right, what if we do this?
Is it because you have an int and it would be negative?
No, an integer can be negative, it just can't be decimal. Yeah, okay, so maybe you can't do both.
It's sad.
But this is good to know. Something I didn't know. It is a little bit sad because it makes me wonder why I can't do something like this, right?
Yeah.
Yeah, because that's the next thing that I would try to say. But from a meta level, this is something that you guys should do all the time. So anytime you're like, what if I did this? What would happen? You could wait for me to reply to email, or you could just like put it into code anywhere and see what happens. So one of the most useful things for your Hello World.java lab is actually because you can hack it all up and add different tests. So, what was initially just Hello World, you can start adding other expressions to, and that's why my Hello World always looks something like this, where there's like the initial Hello World, and then there's some other stuff after it that I was testing. Yes,
I'm Spencer, by the way.
Spencer.
You don't have to use the increment in a print string, do you?
That's right, you don't. So you can have, thank you. You can have this. No, you can't. I'm sorry.
Use
Thank you. Okay, so let's think a second about what's going to happen here. Okay, so initially my val is equal to 1, and then we're assigning my val equal to 1 plus minus my val. So minus my val is equal to 0 at this point. So then my val should now be equal to 1, and then the rest should be the same. So in theory, this is now going to print out 0. Is everybody comfortable with what just happened?
Wait, could you explain what is the first one?
So in the first line here, my val is assigned to 1. In the second line, my val is assigned to 1 plus minus my val, which is at this point equal to 0, because we've pre-decremented it. So now it's 1 plus 0, so it's equal to 1, and then it's 0. Okay, good. I'm really glad that we were able to flesh that out.